Honorable guests, ladies and gentlemen, good afternoon everyone. My name is Puneet Ahuja. I work for a company called Juniper Networks. So I'm here to describe more of infrastructure, or you can say the backbone of any smart city, or whatever smart you think of. And smartness cannot go without IT. Even people think they are smart using a mobile phone. That's again enabled by IT. So I'll be covering few topics over here. I think my slides have gone ahead, so I'll just move it back. If you can reload it once. Yeah, it's okay. So, there are 5 major points I want to cover over here. Starting from why there is a need of smartness, or why we call that we need a smart cities now. Aren't we smart prior? So there are 5 parameters. The first one, and I think the most important is that we want to, overcome the lack of development which was there in our cities prior, and we want to be in line with the latest trends, latest cities which are doing better than us. That's, I think, the most important point. The second one is we want to connect each and everything to everything, so that we can talk to each other. Devices can talk to each other, they can pass on a lot of data to each other, so that that data can be used for analysis, and there can be some decisions can be taken on behalf of that data. Third is digital infrastructure as a utility, which has to be given to every citizen, so they are enabled. Fourth, governance and services on demand, where citizens can demand some type of services, or some departments can demand some type of services from somewhere. It can be it can be a cloud, or it can be a type of service provider. And the fifth is digital empowerment of all the citizens. So these are the 5 major things which a smart city will enable. And until these are there, you can't call a city a complete smart city. To achieve this, it has to be it looks very simple, but it's not that simple actually. We need to have all type of content. I'm sorry, my slides again I think disappeared somehow. So it has to be any content, anytime, to all the people, and there is a lot of real-time data which needs to be analyzed, and this can be done using infrastructure. Ragini is moving on its own. I think we are running it in a MP4 format. It as edge. Then there has to be some type of enablement, so that the edge can pass on data to someone. There has to be a layer which can absorb data which is coming from the edge, from the users, from the devices, from the sensors, and that has to go to a place where that data can be analyzed on its own. So there has to be brain behind it, so that the analysis can be happen, and that analytics will take will help us take many type of decisions. So if you have heard of to just give an example of kiosks, I'm sorry for the slides, but I can give you some examples. In the meantime, the slides work properly. So if you have heard of CM sir was also suggesting that village needs to be smarter. So there can be many services which can be given to villages, like smart kiosk, where you can give type of e-education, or you can have helpline for farmers, or you can have e-healthcare kiosk, where people can go talk to specialists and can get resolution of their services. And another example is if you have heard of vehicles which are driverless, where you don't need to have a physical body to drive a car. There can be sensors which are there in the vehicle. There can be sensors which are there on the highway, and those sensors can help a car to drive on its own basis of some analytics. So there are a lot of embedded electronics which go into the devices, which enable devices to collect data, and which enabled many things to work as per in the optimal manner without manual interference. So I'll go back to my slides. Seems to be okay now. So this slides, I want to convey is, information infrastructure is the fabric of any smart city. That means it's the heart of any smart city. So there are three different pillars. One is devices. Second is network information infrastructure that connect devices, and third is the data center where all of the analytics happens. So these three pillars, if we have in place, we can have any type of smart services running on it. So whether it's education, whether it's healthcare, whether it's intelligent traffic management, whether it's intelligent justice, or policing. Someone was saying that police can be more smarter using this. It can be APNR, where you can read number plates automatically and take decision on the basis of that. You can do many actions. You can have red light violation devices which can sense, and you can generate an e-challan which can go automatically to the users who have violated the traffic rules. There are four challenges as far as IT infrastructure is concerned. The first one is optimization of network. Ma'am was saying that it has to be cost optimized. It should be win-win for user as well as administrator. Second is increased satisfaction of government to government as well as government to citizen services. Third is the security. The security, being whatever infrastructure we are making, whatever data we are collecting, that has to be very secure. That need not to go to the bodies which we don't want to share the data with. Fourth is the latest technology trends, where we want to have some type of infrastructure which not only suffice to our requirement today, but should be able to go to the next technology whenever we want to do so. So there has to be some type of common building blocks for these devices, where we can use them today, but it should be flexible enough to take care of future requirements. Like Tarun was saying IPv6. So IPv6 is a requirement of today as per us. So it has to be, if our network is running IPv4 today, the same network should be scalable or should be modulated to work on IPv6 as and when required. So operational simplicity, cost effectiveness, and the services to the end user, effective services to the end users, can be done using an integrated approach and open approach, where we can have some type of infrastructure which is not only made using common building blocks, but can also suffice to the requirement of today and tomorrow. So again, what we have done over here is we divided that in 4 groups, where there are end devices, there are access, there are aggregation layer, then there is a core super layer, and there is a data center where all the analytics happens. So these are the 5 major pillars where IT infrastructure combined to. You can form any type of network using these 5 blocks. If you want to have a small small sample network, or if you want to make a small POC network, that can also be done using this. If you want to have a bigger network, a complete smart city, then again this can be done using these 5 building blocks. Again, another point I want to make over here is what we have done, even the service provider industry has done, is they have manually fragmented services into 3. First is services itself, then is IP, then is transport. We need to converge this, and we need to synchronize dynamically all the networks which are running parallel, like SWAN, NOFN, NKN. They need to talk to each other, so that there is no parallel, there is no overlap. We can get more return on whatever investment we have made. More data can be transferred from one network to another network, from national network to the states, or states to vice versa. So that need to be taken care. That has to be integrated. Another important point over here is there are many technologies which are available in the market. The best which is suited for, as far as the flexibility and programmability is concerned, is packet-based transport. Because of the 3 reasons. First, it's very efficient. You can have any-to-any forwarding at any point of time. You can have, another important point is low latency. You have fast movement of data. Then it's very dynamic. You can, you can make changes as per the requirement of the network at a point of time. Second important point over here is elasticity. It adopt as per the load availability of the network, and the third is programmability. So you can program, the devices on the embedded CLIs. Another option is you can program on the basis of the requirement of the network itself. So you can customize, you can make your own scripts, and you can, that scripts can be loaded on those devices, and those devices can work in the customized way as per the actual requirement of the end customers, rather than, whatever OEM manufacturer. So these are the three important points as far as the packet-based systems are concerned. These packet-based bigger systems need to be controlled by some centralized orchestration layer. So I think there is a buzzword called SDN, software-driven networking. So that buzzword is again applicable for WAN or WAN infrastructure. So there has to be some orchestration layer which sits on above, can view the complete network on its own, and can take some smart decisions. So I'll take a simple example of Google Map, where you put a location name, whether you want to, like, if you want to go from Badatal, which is in Bhopal, to Noor Sabha over here. So Google Map, what it do is, based on various parameters, is give you the best path to reach to the hotel over here. So there are few intelligence which goes behind the decision. One is, what is the traffic on the ways. There are different ways to reach the same destination. How much congestion is there? How much latency is there? Which path is faster? So on those parameters, Google Map take a decision and give you the best path available at that time. Similarly, the network orchestration layer can also take decision on basis of many parameters like delay, errors, hops, and what is the latency you want, what is the scheduling. Like if some important dignitary is there in this room, and we want to webcast to to other offices or other departments, and in that case we can do some type of scheduling as well. For 15 minutes I want this broadband highway to be free for webcast that CM is want to address some meeting or so. After he goes away, that scheduling goes away, and the network start behaving as normal as it was prior. So another important point over here is another important point, or a place, or an analytics center, or a control room, you can say, is a data center in any infrastructure, where all the data will go, sit, analyze, and you can take many decisions. And another advantage of data center is you can have all the data assembled at one place, so that you can you can use different type of tools to gather whatever information, relevant information you want. Like traffic management will be interested in gathering only information related to traffic. Healthcare will be only the relevant information for those guys will be related to health, or whatever public queries they have. So data center has also taken a leap. I won't take much of time. What all technologies were there prior, and it's whatever they are new. So data center also, there are multiple paths which can take you to the latest technology, which is cloud. So once we, there is a assumptions in everyone's mind that once we go from private data center to a cloud data center, how secure my data will be. So there are ways and means where you can segregate some type of data which can be kept with you, which is very secure. You can place some data in the public cloud where which the data which is not much which can be made public. So there you have you can have a balance, and you can have a hybrid type of network infrastructure over there. So 3 guiding principles. Whatever we make as an infrastructure is this should be keep in mind. First is it should be very simple. It should be open, so that you can customize the network infrastructure according to your requirement. And third, it should be very smart. There are 5 building blocks for any architecture, starting from the foundation layers, which is your electronics, embedded devices, and all this stuff. Then your devices itself. Then you have some type of controllers. Then you have service layer where security takes place, and there is an orchestration layer on above all these, which can take decision and which can make the network really smart. So this is one of my last slide where, I just want to say whatever infrastructure we build today, the desired outcome should be very simple. It should be agile. It should not take much of course. It should be made using, common building blocks which can suffice your requirement today and should, take care of your future as well. Third is it should enhance the experience, which is very important, user experience, and it should preserve your security of your data as well as infrastructure. So I'll leave with the last slide. Thank you very much.